Hello everyone, this is Chandrashekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. So this session is the part of XE series which we started from 5th of February. So this session is the part of XE series Can you guys hear me? So the GATE ME paper is already over and you must have selected XE paper as your second option. So if you are going to appear for XE paper as well as you are going to appear for Civil Engineering GATE 2023 examination, this session is going to be very, very important because FM is one of the common subjects for mechanical as well as civil engineers. So those who are watching me live, please respond through the comment section so that we can start without any delay. So myself, Chandrasekhar, along with Sonu Sir, have brought this session for those who are going to select thermal as well as fluid mechanics as their optional subjects in XE paper. So I will discuss 20 questions from the fluid mechanics first, and after my part is over, Sonu Sir will be discussing the most important 22 questions from the thermal portion. So this session is going to be very, very helpful for all the students who are going to appear in the upcoming GATE exam. So please do let me know if I'm audible and visible to everyone so that we can start. Can you guys hear me? Shall we start the session? You must be knowing that similar to all the other GATE papers, XE paper is also carrying 65 questions in total and the total marks is 100. But the difference here is out of the 7 optional subjects, you are supposed to select any 2. So it might be thermal as well as fluid mechanics or fluid mechanics as well as strength of materials as per your choice, as per your preparation. And one important thing, you can select your choice of 2 subjects after seeing the question paper even. Once you see the question paper, if you find strength of materials difficult, you can select fluid mechanics. If you find fluid mechanics difficult, you can select the thermal engineering. All right. And one more important thing, in the midway of the examination also, you can change your selection. First of all, you need to deselect the previously selected option and then you need to select the other option. If you, for an example, if you solved couple of questions, but the rest of questions you find very difficult, so you can deselect that option and you can select the other one. That is also the option available. All right. So this is my quick introduction for those who are here for the very first time. My name is Chandrasekhar. As I said, I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in GATE, IES and PSUs. And I have also worked in Steel Authority of India Limited and also cleared engineering services examination. And you can connect with me through the mail ID which is there on the screen, chandra.shekhar@byju'sexamprep.com, and you can join me on the Telegram group as well, that is Mechanical by Chandrasekhar. So keep your pen, notebook and calculator ready. Try to solve as many questions as possible. Try to develop the approach. Try to understand the question. Once you are able to solve these questions, then you will develop the confidence to crack your GATE examination with the best possible rank. All right. So as I said, this is the part of XE series which we started on BYJU'S YouTube channel for civil and mechanical engineers from 5th of February. And one important announcement, Dheeraj sir will be coming with a workshop, very, very important workshop for all the GATE 2024 aspirants to give you the most important points to crack GATE 2024 examination with the best possible rank. So do not forget to register for this workshop that is completely free. the link of joining or registering this workshop must be there in the description box of this session. So once the session is over, you can go through the description window, then you will find the link to join this session, which is on 11th of February at 7:30. Day after tomorrow, the workshop will be conducted. All right. So ready with your pen, notebook and calculator. Shall we start? There is the first question on the screen. Question number 1. Read the question and try to give me the answer for this. Rheological diagram of different type of fluids is shown in figure. First question from the fluid mechanics. I will discuss 22 questions which will contain 35 marks. This is the actual pattern of the GATE XE paper. From each of the optional subjects, there will be 22 questions, 9 questions containing 1 mark and remaining 13 questions containing 2 marks. So more questions are there for 2 marks compared to 1 mark question. There are MCQs, MSQs as well as NATs. I hope you are clear with the pattern of the GATE XE paper. So let me know your answer. Column 1 represents the fluid and column 2 represents the curve. Which curve represents which rheological behavior curve represent which type of fluid? So the straight line, it is the curve between shear stress and the shear strain rate, that is d theta by dt or du by dy. Flow rate and shear stress. So you must be knowing O represents the Newtonian fluid. When the curve is a straight line passing through origin, so Newtonian fluid is O, right? Shear thinning fluid. Shear thinning fluid is also known as pseudoplastic fluid. Pseudoplastic fluid, the viscosity, the slope of the curve is the viscosity of the fluid. In pseudoplastic fluid, the viscosity decreases. All right. So P will be pseudoplastic or shear thinning fluids. Viscosity decreases with the flow rate. So P is shear thinning, and shear thickening fluid is also known as dilatant. You must be knowing the examples of these fluids. Shear thickening fluids whose viscosity or the slope keeps on increasing from 0 to with the increase in flow rate. So N will be the shear thickening fluids. Sorry, N will be shear thickening fluid or the dilatant fluid. And Bingham plastic is again a straight line, constant viscosity, but it will not pass through the origin. So Bingham plastic, or we can also call it as ideal plastic, is curve number M. So this is how you can select the appropriate option. Which of the option is representing the correct relationship? Everyone? Which one is that? 1O, C and D cannot be true. 2P, B is the correct answer. 3, N and 4M. Isn't it option B? So question number 2 on the screen. Very simple question. This is the question from the standard result. You must know the standard result for this. In a two-dimensional, incompressible and irrotational flow, stream function and velocity potential function exist. It means the flow is 2D. Stream function only exists for two-dimensional flows, and velocity potential function exists only for irrotational flows. So the flow must be incompressible, two-dimensional and irrotational flow. The velocity in x and y directions are non-zero. Then the product of slope of equipotential line and the slope of streamline will be. What is the answer? Yes, Deepak, very nice. Please share your answer, everyone. Please be there in the session with your full dedication, with your full concentration and your full energy and enthusiasm. Please keep on communicating your answer through the comment section so that your confidence level should boost up. So the product of equipotential line and streamline must be -1, or we can say that streamlines and equipotential lines are orthogonal to each other in the flow field. When both the functions exist, stream function as well as the velocity potential function, it means the flow must be two-dimensional and irrotational. I hope this is clear. Well done, Saket. Can we proceed to the next question? Question number 3 on the screen. The inviscid flow means non-viscous. For the non-viscous flow, or we can call it as irrotational also. If the flow is non-viscous, it must be irrotational or ideal flow. Past a rotating circular cylinder can be generated by the superposition of. This question is from elementary planar flow or flow net analysis of two-dimensional irrotational flows like uniform stream, sink, source, vortex, doublet, etc. So when there is a rotating cylinder kept in the inviscid flow, so it is the uniform stream. Then it will become, if the cylinder would have been stationary, then it will become the doublet. Like this, these streamlines will be like this. This is the doublet. The streamlines will be like this. So it is uniform, then doublet, and because of rotation, it will be vortex due to rotation of the cylinder. So option D is the right answer for question number 3. Isn't it option D? Uniform, doublet, and let me tell you, in mechanical engineering or civil engineering, this portion is rarely asked. But in XC paper, you will find every year, mostly each and every year, you will find one question from this portion of the elementary planar flows. Right? Superposition of the various types of irrotational flows. The next one, the next question, question number 4. So I am having 9 questions for 1 marks. First 9 questions will be carrying 1 marks, and the remaining 13 questions will be carrying 2 marks. All right. The velocity field and the surface normal vector are given by these vectors. Velocity vector is this, and the normal vector is this. If Euler equations are to be solved, the boundary condition that must be satisfied at the wall is. What should be the answer? Yes. What should be the answer to this one? If we draw to a wall, if we draw tangent and normal, the tangent will represent the velocity vector and this will be the normal. At any point we can draw tangent and normal. The tangent will represent the velocity vector and normal vector will be perpendicular to the velocity vector. So we can say V dot N dot product is equal to V normal vector magnitude into cos theta. And what is angle theta? Theta will be equal to 90 degrees. That will be equal to 0. V dot N must be 0. There is no flow across the streamline. You must be knowing there is no flow across the streamline. The flow is always along the streamline. The velocity vector in normal direction will be 0. So the product of normal vector and the velocity vector, dot product of velocity vector and normal vector must be 0. It must be option A. A will be the answer. It should be option A. All right. Clear, everyone? Please keep on talking to me. Keep on asking me the doubt if any. Keep on sharing your answer. The more you involve yourself, the more fundamental clarity you get. The next question, question number 5, again for 1 mark. You will find in GATE XC paper, if you are going for an XC paper, you will find 15 to 16 questions out of 22 questions, very, very simple. Only 5 to 6 questions, 5 to 7 questions, you may find difficulty in solving. Otherwise, the rest of the paper you will find very simple. So it is a golden opportunity. If your gate mechanical paper had not went well, then you can focus on getting good score in XC paper. As you all know, the competition is not that high even, so you can score better and you can book a seat in IIT for MTech through XC paper. All right. What is the answer to this one? Fraud number. The influence of the fraud number. It is the question from the dimensional and model analysis. The fraud number is related to gravity, and gravity is important in case of free surface flow. Yes, the answer to this question is C. C is the correct answer. Clear? And those who are going to appear for engineering services examination on 19th Feb, we are running the marathon session for non-technical portion, or we can call it as paper 1. For paper 1, most of the students skip that paper 1 because generally students focus on the technical portion, which is common for GATE and IES and other competitive examination. So if you are worried about the paper 1 syllabus or the revision of paper 1, you can join our marathon session, which started from yesterday on BYJU'S YouTube channel for civil and mechanical engineers. So if you have not subscribed the channel yet, please do subscribe and do revise the concept or revise the subject which are going to help you to improve your rank, which is going to help you to clear the prelims. So it is going to be very useful session. So do join and ask your friends also to join this session. All right. Vijay, not 1600, registered students are around 4000 to 5000. For XC paper, the total number of students who had registered is around 4000 to 5000. Right? So fair chances of getting the good rank in XC paper. You are having the golden chance of getting the good score in XC paper. Question number 6 on the screen. Now read the question number 6 and try to solve this one. Achha, you are talking about PI. Achha, for PI, yes. Only 1600 students had registered for PI. Right. And out of them, we do not know how many of them are going to appear for the actual exam. So Vijay, that depends on the difficulty level of the paper as well. We cannot say like this. It depends on the difficulty level of the paper. So if the paper is easy, then the score will be high. If the paper will be tough, then the score will be low. So it depends on number of factors. So try to solve the next one, question number 6. If the paper will be easy, so there will be less difference between the marks of the top 10 students. So the next question, if the stream function for a two-dimensional incompressible flow field is given by this expression. This is the stream function, 2yx square minus y square. The corresponding velocity field is. What is the corresponding velocity field? Can you solve it? You must be knowing u is equal to del psi by del y. What is del psi by del y? So if you differentiate this psi with respect to y, then it will be 2x square minus differentiation of 2y cube, that is 6y square, isn't it? And then you can find out v. V is equal to minus of del psi by del x. Differentiate psi with respect to x and put negative sign along with that. So if you differentiate, then it will be minus 4xy. Minus 4xy, isn't it? 2x square by differentiation of. So the velocity field is given by u I cap plus v j cap. So u is equal to 2x square minus 6y square minus 4xy j cap. Isn't it? Or we can write it as 2x square minus 3y square I cap minus 4xy j cap. So the correct answer to this question is, what will be the right answer to this one? It is option B. Isn't it option B? B is the answer. Next question, question number 7. Question number 7. Question number 7 on the screen. Water is flowing in two different tubes of diameters d and 2d with the same velocity. The ratio of laminar friction factors for the larger diameter tube to the smaller diameter tube is. What is the answer? There are two different tubes of diameter d and 2d. The important point here is the velocity in both the pipes is same and the fluid is also same. So the ratio of laminar friction factor for the laminar flow in a pipe, the friction factor is only depending on Reynolds number, isn't it? The friction factor, Darcy's friction factor only depends on the Reynolds number, and Reynolds number is equal to rho Vd by mu. Density is constant because it is water. Viscosity is constant. Velocity is given same for both the pipes. So we can say Reynolds number is directly proportional to diameter of the pipe. And F is inversely proportional to Reynolds number. So F is inversely proportional to diameter of the pipe. Isn't it? For the given condition, the Darcy's friction factor is inversely proportional to diameter of the pipe. So we need to find out the ratio of laminar friction factor for the larger diameter tube to F2 by F1 is equal to D1 by D2, isn't it? And what is D1? That is D. D2 is 2D. So 1 by 2 will be the answer. That is 0.5. That is 0.5. All right, option A is the correct answer. Question number 8. Again, 1 mark question. Question number 8, 1 mark. Solve this one. If the velocity field is given by this expression, then vorticity of the fluid element in the field at x is equal to 1 and y is equal to 2 in second inverse is vorticity about z-axis, because it is two-dimensional flow. The flow is in xy plane, so we need to find out vorticity about z-axis. What is the formula for vorticity about z-axis? So del v by del x minus del u by del y, isn't it? That is the expression for vorticity. So if we compare this velocity profile, with ui cap plus vj cap, then u is equal to xy square, v is equal to 4xy. So if we find out del v by del x, what is del v by del x? That is equal to 4y minus del u by del y will be equal to 2xy, isn't it? And if we put x is equal to 1 and y is equal to 2, then vorticity is given by 4 into 2 minus 2 into 1 into 2. What is the answer? That is the second inverse. The unit of vorticity will be second inverse. Unit of angular velocity will also be second inverse. 8 minus 4, that is 4 second inverse. What is the answer? That is 4. The answer will be 4. All right. The next question, question number 9. The next one is question number 9. Again, 1 mark. The question is from the Bernoulli equation, from the pitot tube. Yes, Vijay, there is a chance you can get. Yes, you can get NIT thermal through GATE PI paper. You need to check which of the NITs will allow GATE PI score for their thermal branch. But mostly all the general science MTech, engineering science, MTech in engineering science, like ocean engineering, like hydrology, or like aerospace engineering. So these are all open for PI. But you need to check which NIT will allow the PI score for their MTech in thermal. A pitot static tube is used to measure air velocity in a duct by neglecting losses. The density of air is 1.2 kg per meter cube if the difference between the total and the static pressure is 1 kilopascal. So this is the pitot tube. This is like the pitot tube. This is 0.2 where the velocity is 0. So it will represent the stagnation pressure head or the total pressure head. This is 0.1. Here it will be the static pressure head. So the difference of these two pressure is 1 kilopascal. So we can say P2 minus P1 is given as 1 kilopascal. What is the velocity of air at the measuring location V1? The question is to find out V1. The fluid is air. So because losses are neglected, so we can say V1 is equal to under root 2g, then P2 minus P1 by rho g, isn't it? Under root 2gh. So g and g getting cancelled out. So under root of 2, P2 minus P1 is 1 into 10 to the power 3, 1 kilopascal upon rho, that is 1.2. Do the calculation and let me know the answer. Please do the calculation and let me know the answer to this. What is the answer? What is the value of P1? 2000 divided by 1.2 and take the under root of this. Isn't it 40.82? 40.82 meter per second. For NAT type question, you will find the range. And if your answer is within the given range, then only it will be treated correct. Now the next question, question number 10, starting with 2 marks. There are 22 questions in total. So this is question number 10, carrying 2 marks. Read the question and try to solve it, everyone. there is a parallelepiped of 2 meter by 2 meter square cross section and 10 meter in length. It is a cuboid, is partially floating in water up to a depth of 1.2 meter. It is partially floating, with its longest side being horizontal. It means the length is horizontal. So it is something like this. This is how it is floating in water. And the depth of immersion is 1.2 meter. This is 1.2. 1.2. And this is 2 meter. This is also 2 meter. The cross section is 2 by 2. Here is the free surface. So it is partially submerged like this. Now, the specific gravity of the block is, what is the specific gravity of the block? That is density of the block divided by density of water. The fluid is water. The fluid is water. So that is to be calculated. Can you solve it? Because the parallelepiped is in vertical equilibrium, so weight of the body must be equal to buoyant force exerted by water. For vertical equilibrium, weight must be equal to buoyant force. So weight of the body must be equal to buoyant force by water. And how to write the weight of the body? That is density of the body into volume of the body total volume, 2 into 2 into 10 into G, M into G is equal to buoyant force by water is density of water into volume of the displaced fluid. This will be the volume of the displaced fluid. That is equal to 10 into 2 into 1.2 into G. G getting cancelled out. 2 and 10 are also getting cancelled out. So density of the body upon density of water, that is specific gravity of the body, will be equal to 1.2 divided by 2. That is equal to 0.6. That is equal to 0.6 for vertical equilibrium. Because the body is in vertical equilibrium, and for vertical equilibrium, weight must be equal to buoyant force. Question number 10, option B is the right answer. All right. And from 15th of February, you can check your rank in your GATE paper. And accordingly, you can plan for further preparation. So BYJU'S Exam Prep is bringing the rank predictor tool, which will be live from 15th of February. You can register yourself for the same. Question number 11, again carrying 2 marks. Question number 11. The velocity field in a two-dimensional unsteady flow is given by this expression. It is unsteady flow. Velocity is a function of time. The magnitude of acceleration of the fluid particle located at x is equal to 1 meter, y is equal to 1 meter, and at time t is equal to 1 second in meter per second square is. What is the total acceleration? So from here we can say u will be equal to 2xy square and v is equal to 3xy into t. T is the time. What is t? T is the time. So we need to find out the acceleration at these points at t is equal to 1 second. So acceleration in x direction, ax is equal to u into del u by del x plus v into del u by del y plus del u by del t, local plus convective acceleration, because u is not a function of time. This will be 0. So put the value, u is equal to 2xy square into what is del u by del x, 2y square, plus v, that is 3xyt into del u by del y, that is 4xy, and at x is equal to 1, y is equal to 1, t is equal to 1. What is the value of ax? Ax will be equal to, it will be 4 plus 12, that is 16 units. Ax will be equal to 16 units, isn't it? This is ax. Similarly, we can find out ay. What is ay? U into del v by del x plus v into del v by del y plus del v by del t. So u is equal to 2xy square. 2xy square into del v by del x. Let me write u is equal to 2xy square. V is equal to 3xyt into del v by del x, 3yt plus v, that is 3xyt into del v by del y, 3xt plus del v by del t, that is 3xy. So at x is equal to 1, y is equal to 1, t is equal to 1, it will become 6, it will become 9, plus it will become 3. How much is that? 18, isn't it 18? So ay will be equal to 18, ax is equal to 16. So the magnitude of total acceleration is under root of ax square plus ay square. That is under root of 16 square plus 18 square. What is the answer? Under root of 16 square plus 18 square. What will be the answer? Are you getting 24.08? Do let me know if you are getting 24.08 or not. Meter per second square. 24.08. So 24.1 will be the correct answer for this. Clear? Anybody is having any doubt? If the question asked you only about ax, then your answer would have been 16, option A. And if the question would have asked you only about ay, then your answer would have been 18. But it is the total acceleration, magnitude of the total acceleration we need to find out at the given point. So 24.08 will be the final answer, or 24.1. Aspirant, if you have missed only by few marks, then it is better to concentrate, because you can clear the ESC this time. So better you concentrate on ESC, and because the technical syllabus is more or less same for ESC and other examination, you can appear for other examination as well as parallelly. But focus on ESC right now, because you have already studied last year and you have missed only by few marks. So you can make it this time. There is a fair chance. Yes, right? The next question, question number 12. Once fluid mechanics will be completed, then Sonu sir will be bringing the important, beautiful questions from the thermal part, thermodynamics and its application for upcoming XC paper. All right. So question number 12, again carrying 2 marks. Read the question again from the kinematics. The question is from the kinematics. In a two-dimensional, incompressible and irrotational flow, fluid velocity in y direction is given by this expression. The velocity in x direction is, because the flow is two-dimensional and incompressible as well as irrotational. So if we write continuity equation, for two-dimensional incompressible flow, then we can say del u by del x plus del v by del y must be equal to 0. So del u by del x is equal to minus of del v by del y, isn't it? And what is minus of del v by del y? That is 5. Isn't it 5? It will be 5 because there is a negative sign already there. So if we integrate this with respect to x, then u is equal to 5x plus the constant can be a function of y. Then if we differentiate with respect to y, then we can say del u by del y is equal to f dash y, isn't it? So how to find out del u by del y, which is f dash y? Again, because the flow is irrotational, The flow is irrotational, and for irrotational flow, vorticity about z axis, that is del v by del y, del v by del x minus del u by del y must be 0. So del u by del y can be written as del v by del x. And what is del v by del x? V is given, del v by del x is 2. Isn't it 2? So put the value, put in equation. This is, let us say, equation number 1. Put the value in equation number 1. So put in equation number 1. Then we can say f dash y is equal to 2. If we integrate this with respect to y, then fi will be equal to 2y. So put in earlier equation, this is our expression. So u is equal to 5x plus 2y, isn't it? So u is equal to 5x plus 2y will be the answer. 5x plus 2y will be the answer for this. C is the correct answer. C will be the right answer for this one. Question number 13. Again for 2 marks, and the question is from the Newton's law of viscosity. The question is from the Newton's law of viscosity. Can you solve this one? Give it a try, everyone. A two-dimensional laminar viscous liquid film of constant thickness H. This is the thickness H. It is already mentioned here. Na? Yes, the thickness of the fluid is H. Steadily flows down an inclined H1 in figure. The angle of inclination is theta with the horizontal. Acceleration due to gravity is g. If the velocity profile in the liquid film is given by this expression, there is no velocity in y direction. V is equal to 0. Only the velocity variation is taking place in x direction. The value of constant k will be. What is the value of k? Value of k. So can we say according to Newton's law of viscosity, tau is equal to mu into du by dy? And tau naught will be equal to mu into du by dy at y is equal to 0. Can we write the surface shear stress, and that is equal to the shear force upon shear area, isn't it? Shear force upon shear area. So this is the Newton's law of viscosity. So what is du by dy? If we find out du by dy, then it will be 2kh minus ky square. So 2ky, and at y is equal to 0, what is du by dy? So at y is equal to 0, du by dy is equal to 2kh. So if we write tau naught is equal to mu into 2kh is equal to force. Shear force is the component of the tangential component of this weight. Weight is acting in downward direction. This angle will also be theta. If the angle of inclination is theta, so this angle will also be theta. This will be the normal force, W cos theta. This is the tangential or shear force, that is W sin theta, isn't it? So W, what is W? That is weight m into g. So we can say density into volume. What is the volume of the fluid? We can write it as A into H into G into sine theta upon area. This is the fluid we are talking about, upon area. So if we equate this, then you will get the value of K. Isn't it? Area getting cancelled out. H and H is also getting cancelled out. So K will be equal to rho G sine theta upon 2 mu will be the answer. Rho G sine theta by 2 mu. All right. Option A is the right answer for this one. Option A is the correct answer. So please guys do like this session so that it reaches to all the students who are going to appear for civil engineering, civil GATE civil paper as well as XC paper. The next question is from the momentum equation, application of momentum equation, question number 14. NAT, 2 marks. Can you solve it? A water jet of 100 mm diameter. This diameter is 100 mm. Issuing out of a nozzle at a speed of 50 meters per second, strikes a vein and flows along it as shown in figure. It is flowing along the vein. The vein is attached to a cart which is moving at a constant speed of 20 meters per second. That is U. Velocity of the jet is 50 meters per second. The jet is deflected at an angle of 30 degrees. Take the density of water as 1000 kg per meter cube. Neglect the friction between the vein and the fluid. The magnitude of the force exerted by water on the cart in X direction is. So we need to apply the momentum equation in X direction. That is for sure. So if we talk about the control volume, if we talk about this control volume, this is our control volume, let us say. And we are going to apply momentum equation in this is our control volume. This will be our control volume. And we are going to apply the momentum equation in X direction because we need to find out the force exerted in X direction. But because the cart is moving, so the control volume is also moving. And moving control volume will make the flow unsteady. And to make the flow steady, we need to sit on the control volume. To make the flow steady, the control volume should be fixed by sitting on the control volume. If we sit on the control volume, then we will write the momentum equation. So initial velocity of the fluid, if you sit on the control volume, then we will find out the initial velocity to be V minus U, and the final velocity will also be V minus U. I am calling U to be the velocity of the cart. So initial momentum, so the force exerted in normal direction is the rate of change of linear momentum. So rho into jet area into V minus U. That is mass flow rate into change in velocity in X direction. So initial velocity is V minus U. Then final velocity is V minus U cos 30. Isn't it? This will give the force in normal direction. Or we can say rho into pi by 4 d square into V minus U square 1 minus cos 30. Put the value, you will get the answer. 10 to the power 3 pi by 4. Diameter is 100 mm. 0.1 into V minus U. So it will be 50 minus 20 square. 1 minus what is cos 30? Under root 3 by 2. What is the answer? That will be the answer. The force exerted on the cart, Fn. Rate of change of linear momentum of the fluid. It is initial momentum in X direction minus final momentum per second of the fluid in X direction. That is the force exerted on the cart. So if you will solve this, then you should find the answer to be, are you getting 947? Please do let me know if you are getting 947 Newton or not. 947 will be the correct answer. Isn't it? This is one of the beautiful questions from the dimensional analysis. This is very, very beautiful and important question. Now try to solve this question. Everyone, please give it a try. Solve करिए इसको. Capillary waves are generated in the sea. The speed of propagation of these waves is known to be a function of density, wavelength, and surface tension. So the speed of propagation of the wave is a function of density, lambda, and sigma. If the surface tension is doubled in the functional form of relevant non-dimensional group, the percentage increase in propagation is. So C2 minus C1 upon C1 into 100 we need to find out. Or we can say C2 by C1 minus 1 into 100. That need to be calculated. So we need to find out how C is related with sigma. That is our objective. Look, how to develop the relationship? We can say C can be written as some constant into rho to the power A, lambda to the power B, and sigma to the power C. We need to find out this value C, isn't it? So this is the speed. We can say L1 T minus 1 on the left hand side, dimensional formula. Constant is dimensionless. Rho is M1 L minus 3 to the power A. Lambda is L1 to the power B. Lambda is wavelength. The unit dimensional formula is L1. Sigma is Newton per meter or kg per second square. So M1 T minus 2. M1 T minus 2 to the power C. Separate the variables. L1 T minus 1, we can call it as M0 is equal to M to the power A plus C. Isn't it A plus C? Then L to the power minus 3A plus B. Minus 3A plus B. Yes. Then T to the power minus 2C. So equate the dimension. So minus 2C is equal to minus 1, or we can say C is equal to 1 by 2. We are interested in C only because everything else is constant. Rho is constant, lambda is constant. So because C is 1 by 2, so from here we can say C will be proportional to sigma to the power 1 by 2. The speed of propagation of the wave is directly proportional to sigma to the power 1 by 2. That is C, isn't it? So if we want to find out C2 by C1, then sigma 2 by sigma 1 under root. And if that sigma is doubled, so it will be root 2. And root 2 is 1.414. So C2 minus C1, or we can say it will be 41.4% will be your answer. 41.4% will be the answer. Yes, Sonu Sir is already there waiting to start to discuss the beautiful questions from thermal engineering. So please guys do like and share so that more and more people can join and get benefited. All right. So you should continue your preparation for XC as well. Do not relax. Relax after the GATE examination is over. For a couple of days only, then again you need to continue your journey of preparation. All right. Next question. Question number 15 is already done. Question number 16. Carrying 2 marks, and it is again NAT type question. Consider a fully developed 2-dimensional and steady flow of a viscous fluid between 2 fixed parallel plates. Normally, parallel plates is less important compared to the flow in a pipe, viscous flow. It is laminar flow, separated by a distance of 30 mm. So the distance between the parallel plates is 30 millimeter. The dynamic viscosity of the fluid is this, and the pressure drop per unit length, delta P by L. Delta PL by L is 300 Pascal per meter. The fluid velocity at a distance of 10 mm from the bottom plate is. So first of all, you need to remember the formula for velocity, 1 by 2 mu minus dP by dx into hy minus y square. This is the formula. Bottom plate means y is equal to 0. This is the bottom fixed plate, and the top fixed plate is having y is equal to h. So put the value at y is equal to 10 mm. We need to find out the velocity. Simple question, formula based. 1 upon 2, viscosity is 0.01 minus dP by dx, that is delta PL by L. We can call it as minus dP by dx as well. So that is equal to 300 Pascal per meter. And h, what is h? 30 mm. So 0.03 into 0.01 minus y square 0.01 whole square. This will give you the value of u. What is the answer? Please do let me know what is the answer to this one. Please let me know the answer to this one. Can you solve it? The answer, are you getting 3 or not? Are you getting 3 meter per second or not? The answer will be 3. Isn't it? Let us move to the next one. Question number 17. Again carrying 2 marks. Question number 17. The question is from the drag and lift. A 2.6 gram smooth table tennis ball has a diameter of 38 millimeter. The density of air in which the table tennis ball is kept is 1.2 kg per meter cube. Neglect the effect of the gravity. Take coefficient of drag as 0.5. CD is given as 0.5. If the ball is struck with an initial velocity of 30 meter per second, u is equal to 30 meter per second. The initial deceleration in meter per second square is. This is the ping pong ball. If the ball is moving with 30 meter per second, then the drag force by air will act in the direction opposite to the motion. This is how the air will blow. So air will exert a drag force like this. So FD is equal to minus MA, isn't it? So that is the deceleration. So FD is equal to M into A. That is the negative acceleration, because acceleration will be because it opposes the motion. Drag force opposes the motion. So this is the deceleration. Yes, Varun, tell me. So CD into projected area of the ball into rho u square by 2 is equal to mass into deceleration. CD is given as 0.5. The value of CD is given as 0.5. The value of CD is 0.5. Projected area is pi by 4 d square. What is the diameter? 38 mm. So 0.038 square into density 1.2 into u square, that is 30 square by 2, is equal to 2.6 into 10 to the power minus 3 kg into acceleration. So we can find out the value of acceleration. Can you solve for acceleration? Can you find out the value of acceleration? Actually, it is deceleration because it is opposite to the motion of the ball. Drag force opposes the motion of the ball. So the deceleration will be equal to 117.77 meter per second square. It will be 117.77 meter per second square, isn't it? So I am having 5 more questions to go, and then Sonu sir will be taking over the charge from here. The next question, again beautiful one, from the boundary layer theory. The next question, please try to solve this. On a flat plate, transition from laminar to turbulent boundary layer occurred at a critical Reynolds number. You all know the transition from laminar to turbulent takes place at the critical value of Reynolds number. Yes, Abhi, well done. Good, good, good. No, it is not. No, it is not necessary to get selected in IIT Bombay. Varun. Yes, Varun. In BARC exam, the entry is through both the options, either from GATE or from their own written examination as well. So if you are not able to get the entry through GATE examination, then you can appear for their on individual written examination, and you can get DGFS. Yes. So the flow, the transition from laminar to turbulent takes place at the critical value of Reynolds number. The empirical relation for the laminar and turbulent boundary layer thicknesses are given by this. Laminar and turbulent. The first one is for turbulent and the second one is for, it is actually right. Yes. Second one is for laminar. LAM is laminar, TURB is turbulent. Respectively, the ratio of laminar to turbulent boundary layer thicknesses at the location of transition is 0.3. So delta laminar divided by delta turbulent is given as 0.3. What is the value of critical Reynolds number? Yes, Varun, that is what I am telling you. Yes, Abhi, what is your doubt? You need to find out the critical value of Reynolds number. What is the critical value of Reynolds number? So can we say, so that will be equal to, at the transition, delta laminar is equal to 5.48x into Reynolds number to the power minus 0.5 divided by delta for turbulent is 0.37 into x into Reynolds number to the power minus 0.2. Right? X and x getting cancelled out. So delta laminar for delta turbulent is 0.3. So what we can write? So it will be Reynolds number to the power minus 0.3 is equal to 0.3 into 0.37 upon 5.48. So this is the critical value of Reynolds number we will be getting. So critical value of Reynolds number is equal to 0.3 into 0.37 upon 5.48 to the power minus 1 upon 0.3, isn't it? Or we can say 10 by 3. Or we can say 5.48 upon 0.3 into 0.37 to the power 1 upon 0.3. So that will give you the answer. That will be the critical value of Reynolds number. Varun, for both the post OCES and DGFS, you can have the entry through GATE examination also. Both are open through GATE also, and both the posts are open open through individual examination as well. Right? Yes, Abhi, well done. It will be around 441369. 441369.32. That will be the, or we can say 4.4 into 10 to the power 5. 4.41 into 10 to the power 5. That is the critical value of Reynolds number. This will be the answer. So for NAT questions, there will be range given. And if your answer is within the given range, then it will be treated correct. The next question, question number 19. Question number 19. From the laminar flow in a pipe, in a capillary tube of radius 0.25 mm, A fully developed laminar velocity profile is defined as this. They may not give you the velocity profile. You should remember the formula for velocity profile for laminar flow in a plate, in a pipe. In this expression, minus dp by dx or pressure drop per unit length is 1 megapascal per meter. Mu is the dynamic viscosity of the fluid, and small r is the radial position from the center line of the tube. If the rate of flow through the tube is 1000 millimeter cube per second, the viscosity of the fluid in pascal second is. If you remember the formula, we need to find out the viscosity in pascal second. If you remember the formula for discharge for laminar flow in a pipe, so this will be pi by, what is the formula for discharge? Dp by dx into r to the power 4, isn't it? So from here we can find out the value of mu, that is pi by 8 into q minus dp by dx into r to the power 4. So pi by 8 into what is discharge, that is 1000 millimeter cube per second. So 1000 into 10 to the power minus 3 to the power 3. So it will be 10 to the power 3, that is 1000 into 10 to the power minus 3 cube into minus dp by dx 1 megapascal. So 1 into 10 to the power 6 into radius. What is the radius? 0.25 mm. It is 0.25 mm. So it will be 0.25 into 10 to the power minus 3 to the power 4. That will give you the answer. Isn't it? So if you see this 10 to the power minus 3 cube into 10 to the power 3, this will become 10 to the power minus 6. And if you see, this also will become 10 to the power minus 6. Isn't it? So this will get cancelled out. So it will be pi into 0.25 to the power 4 upon 8 pascal second will be the answer. Pi by 8 into 0.25 to the power 4. What is the answer? Isn't it? Is it 0.001534 pascal second? 0.001534. Isn't it? 0.001534 pascal second will be the answer. I hope this is clear. If anybody is having any doubt, you can just let me know. Question number 20. 2 more questions to go after this. Question number 20. Again NAT. Carrying 2 marks. A 150 mm by 150 mm square pillar is located in a river with water flowing at a velocity of 2 meters per second. Water is flowing at a velocity of 2 meters per second. As shown in figure, the height of the pillar in water is 8 meters. Right? Take density of water as 1000 and kinematic viscosity is 10 to the power minus 6 meters square per second. The coefficient of drag of the pillar is 2. Coefficient of drag is 2. The drag force exerted by the water on the pillar is. So very simple, drag force is equal to coefficient of drag into projected area into rho v square by 2. Formula based, coefficient of drag is 2. Projected area will be this area. Isn't it? So it will be 8 into 8 meter by 150 mm, 0.15 into density of water 10 to the power 3 into v square, that is 2 square by 2 will give you the answer. What is the drag force? What is the answer? This 2 getting cancelled out with this 2. What will be the answer? Are you getting 4800 Newton or not? Are you getting 4800 Newton? Isn't it? This is the last question. This is your assignment question. Now I will invite Sonu Sir. Sonu Sir, are you there? Let me check if Sonu Sir is there or not. So now Sonu Sir will be coming and will discuss. I have brought one question less. This is your assignment question for this. Let me check with the Sonu Sir. If anybody is having any doubt, you can just let me know. And prepare well. There are some topics in fluid mechanics which are not part of GATE syllabus though. So you should prepare those topics also. All right. Like I have already told you, like there are rarely questions are asked from hydraulic machines. No questions are asked from hydraulic machines. That is not important. But notches, wears, as well as these potential flows, elementary flows, source, sink, vortex, superposition of the elementary flows. These are important. Uniform stream. So these are important. The questions are normally asked from these areas. So prepare well, guys, and see you there. We will have the analysis also for XC paper after your examination is over. On 11th, we will be going to have the analysis of XC paper. So do join us for the analysis also. All the very best. And now I would request Sonu Sir to take the charge from here. Please stay there till the end of the session. He will bring very, very important and beautiful questions from the thermal part of XC paper. All right. Thank you, guys. Thank you very much. Take care.
Okay. So very good evening to all of you. Before starting the session, just let me know is my audio video clear or not. After that, we all are going to discuss a very important portion of mechanical as well as XC paper, my dear. You write first. Is my audio video right or not? Is everything fine? Can we start now? Yeah, give me 1 minute. I'm just connecting the YT. Okay, good. So chaliye, just like the session and share with your friend, my dear. We are going to start the XC paper thermal part. 22 question you have already discussed. You have already solved by, that was conducted by Chandra sir. 22 question I am going to discuss related to thermal. This is all about me. We are not stopping for so much of time because already the time is very important. Yes, one two important update I am going to discuss with you. One free workshop is conducted by Dheeraj sir. Topic will be 7 success mantra if you are going to prepare for GATE 24. That will be live on 11th of Feb and time will be 7:30, my dear. If you are the aspirant of GATE 24, then definitely you must join. After that, a very important discussion I and Dheeraj sir is going to have tonight, my dear. Yes. नहीं अब सॉम नहीं है, थर्मल आ गया. नहीं मतलब सॉम भी पढ़ाता हूँ, थर्मल भी पढ़ाता हूँ. आ जाओ यहाँ पे. Okay. So if you are scoring low marks in GATE Mechanical 23, my dear, then definitely this session is for you because maximum number of students are texting us or या तो call कर रहे हैं and then definitely maximum of you are feeling depressed कि सर ये नहीं हुआ वो नहीं हुआ. So on these all the things me and Dheeraj sir is going to have a very important talk with you guys tonight at 11 p.m. So do join the session on the YT. It will help you to take the decision what exactly you need to do and it will also give you the clear cut idea कि आपने कितने marks किए, सही थे कि गलत थे, वो अलग चीजें. चलिए. XC questions are starting from here. Question number 1, I'll expect the correct answer from you. Sir, up to the question number 10, level of the question is quite easy. You know the reason because it is the 1 marks question. 1 marks के question है हेमांक. वेयर आर योर फ्रेंड्स? वो अजय पता नहीं कहाँ है यार, अजय नहीं दिख रहा है. हेमांग, ओके. So these are the 1 marks question, and for the simplicity let me tell you I've just combined few GATE XC papers so that you will get the clear cut idea कि कहां से क्वेश्चन आते हैं, कौन कौन से पॉइंट्स रहते हैं. Yes, so that you will have a little bit idea of this one. Okay, so answer is absolutely right. What is the answer? D for Delhi is the answer. Pressure is purely independent from the mass. Enthalpy is the function of mass. Internal energy, entropy, all three are the function of mass. Not answer. Answer is D for Delhi. Let's move forward. Thermodynamic process for a substance is represented at a constant pressure process on PV diagram. It's an isobaric process on PV diagram, and it's also the isothermal process on VT diagram. Okay, it's done. Good. It is the process of phase change. Let me tell you again, my dear, this list of the question is purely the previous year XC, so that you will get the clear cut idea कैसे expected question आते हैं, कहां से आते हैं, what mistake we need not to do. You will get the clear cut idea. Third one, when the fixed mass of air water vapor mixture is heated at a constant pressure, then which of the following is the correct statement? Most air is heated into a chamber and the process is the isobaric process. I am going to tell you again, my dear, up to the question number 9 you feel very easy to solve any question. बहुत आसान क्वेश्चन आपको लगेंगे. Where are these all your friends? ये आ नहीं रहे. Anyone? Abhi, I am waiting for the correct answer, my dear. Hemang, you have written B answer. B for Bombay, that relative humidity will decrease, but according to you, specific humidity, absolutely right. Let me share a short introduction for all of you who have not tried this question. Sir, it is the psychromatic process. Whenever pressure is not changing, then line is drawn like this. This is the specific humidity line. This is the dry bulb temperature line. So my dear, definitely relative humidity will decrease because it decreases from left to right. But specific humidity is remain constant because it is a horizontal line. Absolutely right answer. Very good, Oman. XC. How much rank you are expecting, Hemang? How much rank you are expecting? It must be less than 50. If your maths and aptitude is good, then you can't feel the problem. बहुत ज़्यादा प्रॉब्लम नहीं होगी अगर मैथ्स और एप्टीट्यूड बहुत सही है तो. You are performing well. If your maths and aptitude is at the same level, whatever you are going to write the answer in thermo, in at least in my session, then definitely, my dear, you are going to score well in this XC paper. ऐसा नहीं कि हर बार वो मैकेनिकल का थोड़ा बहुत बिगड़ा तो बार बार बिगड़ता ही रहेगा. नहीं बिगड़ेगा, डोंट वरी. यस. नहीं वही मैं कह रहा हूं, अगर मैथ्स और एप्टीट्यूड अच्छा है तो 50 से कम की ही एक्सपेक्ट रखना. रीजन हार्डली 4 to 5,000 स्टूडेंट हैव जस्ट फिल द फॉर्म and near about 50 to 60% only are going to write the GATE exam. एक्सी में बहुत कम स्टूडेंट लिखने जा रहे हैं. मैं होप की बात, यस, आई एम टॉकिंग अबाउट योर एग्जैक्टली एक्सपेक्टेशन. मैं ये नहीं कह रहा कि कब आएंगे, बहुत अलग बात है. यस, टेल मी द आंसर. द एडिशन ऑफ द रीहीट प्रोसेस, आई एम टॉकिंग अबाउट द रीहीट रैंकाइन साइकिल. बिकॉज ऐसा नहीं कि आपकी किस्मत हर बार आपसे खेल खेलती रहेगी. थोड़ा बहुत अप्स डाउन हुए एंड मैकेनिकल पेपर डिफरेंट थिंग, लेट इट गो. उसके चक्कर में एक्सी नहीं बिगाड़ना है. एक्सी में अच्छा स्कोर ले आओ, देन डेफिनेटली नीति बॉम्बे इज वेरी 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 गुड ऑप्शन. नीति बॉम्बे फॉर यू. यस, सी इज द करेक्ट आंसर. नो my dear, in rank, these are the small points you need not to forget. In the Rankine cycle or in the Brayton cycle, there is only one difference, that in the Brayton cycle, my dear, in the Brayton cycle, work done increase but efficiency does not increase. But in the Rankine cycle, both increase. Work done, efficiency both increase. Okay. Net output increase because of TS diagram area, efficiency increase because of the mean effective temperature during the rejection and the heat supply. Next, question number 5. A Carnot cycle implemented using an ideal gas in a piston cylinder arrangement. Very twisted question. In these questions, maximum of a student can feel the problem. Avi, what is the right answer? Carnot cycle you have already studied in the first year. आप पहले साल में पढ़े हो Carnot cycle. You are the first year student already. You have told me. So I am expecting you are going to write the correct answer. And this is the little bit confusing question because for maximum of you this may be the 2 work transfer process and 2 heat transfer process. But in this one, let me tell you, my dear, in Carnot cycle all 4 processes are the work transfer process, but the heat transfer are only 2 process. These are the isothermal process. So in isothermal process, my dear, the heat is transferring, but in all the process like isothermal and my dear adiabatic, work is done. Okay, so work is done in all the 4 process. Heat is transferring in isothermal process only. Good, very good. Next, this was the XC question in 2019. शायद मुझे डिस्कस करने की भी जरूरत नहीं पड़ेगी. What is the degree of freedom at the triple point? All the points are fixed. You need not to define anything at the triple point. Each and every property is fixed, my dear. Delhi is the answer. Good. Good, Avi. Yes. Little bit twisted question. It's a little bit twisted question for you guys. The differential equation of the Gibbs function for the simple compressible system can be written like this, that dg will be equal to vdp minus of std. Very important. Then what is the numerical value? That is ds over dp under the temperature constant. What will be the answer? This is for you. Very good, Abhi. Abhi, you are in first year, your concept are very good. You just focus on all competitive exam in the final year. Till the final year, if your direction is exactly for the competitive exam, then before the final year you can score well. Because first year में लोगों को पता ही नहीं होता है कि what is the Carnot cycle, how many processes are there in Carnot cycle. No, exactly. Not all the questions, but few questions whatever you have studied ना, आपके अच्छे answer आ रहे हैं at least. Yes. So we know very well from the Maxwell equation, my dear, we can write that it will be written like dV, is it or not, over dt having the pressure constant. It means it is the differentiation of the volume with respect to temperature. Yes, let me tell you, Hemang, and all of you who are just attending the session. Sir, if you are going to write the GATE exam now, then in XC, then again, I think 2 or 1 days are left. Most of the time, at least 1 to 2 questions are asked directly or indirectly. One from the van der Waals equation. वो कहीं से टेढ़ा मेढ़ा करके van der Waals equation को ले ही आता है. And one question from the thermodynamic relation. Because most of the question in this XC paper are asked from basic thermodynamic. And in basic thermodynamic, घुमा फिरा के 4-5 टॉपिक ही बचते हैं. So thermodynamic relation and pure substance topic, real gas equation. These are the most expected topic for the XC. All the 4 Maxwell equation, DH equation, DU equations, exactly. Last year में, सिर्फ last year में नहीं, last years की बात कर रहा हूं. एक क्वेश्चन आपको कहीं ना कहीं घुमा के van der Waals से मिल ही जाएगा. So let's solve it. So in this case, my dear, if the ideal gas equation is there, then PV is equal to MRT. Is it or not? Specific we are talking about. That's why PV is equal to RT. So in this case, I need to know that V is equal to RT divided by P. Then do the differentiation of this equation, that dV over dt, my dear, having pressure constant, capital T, having pressure constant, this value will be equal to R by P. Are we not getting B answer? ये छोटी छोटी चीजें हैं. And these only the thing can make the difference. ये सारी चीजें आप याद नहीं कर सकते हो, करके कोई फायदा नहीं है. How you just utilize presence of mind at that time, it matter a lot. ये वहां पे तो यही काम करेगा. Okay. Let's come to the 8th question. I think there is no issue in it. इसमें तो किसी को कोई प्रॉब्लम नहीं होगी. Even I am not going to discuss this question. A Carnot engine received the 2000 heat from the source of this one, reject 5000 heat to the sink. What will be the, like this? Carnot engine is given. Reversible heat engine is given to us. Heat rejection, heat supply, T lower, T higher. Heat rejection, then heat supply, T lower I need to calculate, divided by T higher is 1200. Tell me the answer. 4 times and 3 times. Are we not getting T2 is equal to 300? Is it or not, Abhi? Yes, 300 is absolutely right answer. You may take a long time, but definitely you are getting this answer. हो सकता है थोड़ा सा ज्यादा टाइम आ जाए, but answer आ रहा होगा आपका. 9. A closed vessel contains the pure substance with 0.5 meter cube of saturated liquid and 0.9 meter cube of saturated vapor. Specific volume of the liquid and vapor is given to us. Then percentage of the vapor, percentage of vapor. He's talking about the dryness fraction on the mass basis. I'll give you 1 minute to solve this question. If you study already, very good. Yes, Avi. Good. Yeah, the same question. You have written in the term of W divided by heat supply. I have written in the term of heat reject divided by heat supply. Both the things are the same. Yes. दोनों चीजें ही सेम है. Don't worry. Important question is there. There is a container, my dear, a closed vessel. It is clearly mentioned like this. In this vessel, two important things are filled. One and second. Liquid and vapor both are filled like this. In this one, it is given vapor of the liquid, volume of the liquid is, my dear, 0.9 meter cube, and the volume of 0.1 meter cube, and volume of the solid is 0.9 meter cube. Now you need to tell me what is the value of the dryness fraction. What is the numerical value of the dryness fraction? Sir, we know very well that total value of the liquid, it will be equal to mass of the liquid into specific volume of the liquid, that is 0.9. If I will substitute, or I just want to know what is the mass of the liquid, it will be equal to, my dear, 0.9 divided by specific volume of the liquid. What will be specific volume of the liquid? That can be written as 0.9 divided by specific volume of the liquid. What is the specific volume of the liquid? 0.000843. This one is the mass of liquid. Similarly, if I'll write the mass of the vapor, that will be equal to 0.1. Again, मैंने फिर से उल्टा लिखा है. Yes, again I have written the reverse. Because this one is 0.1, this one is also 0.1, this one is 0.9 divided by, what is this? 0.0267. After that, you substitute this value, kg, then dryness fraction will be equal to mass of the vapor divided by mass of the liquid plus mass of the vapor. Percentage will be equal to 22.12%. Is it or not? 22 point this one. If you want to check, we can write 0.9 divided by 0.0267. 33 is the mass of this one, and this 0.1 divided by 0.000843, it is 118.62. Yes or no, Hemang? So 33.7 divided by Yes, 22.12. Absolutely right. Yes. Next important question is there. A guess over the van der Waals equation of the state like this, where A and B are given to us, then what will be the van der Waals equation? What is the van der Waals equation, do you think, my dear? What is the compressibility factor for a very high specific volume? What is this value of the compressibility factor? Let me give this value. This is given by PV divided by RT, my dear. This is the compressibility factor equation we know very well. Anyone? Can you please write the answer in comment section? What is the correct answer you all guys getting, my dear? Because from here we can substitute the value of the pressure will be equal to RT divided by V minus B minus of A divided by V square. If we substitute all the value, let's see what exact value you all are getting, my dear, from here. You everyone, what exact value you all guys getting? Let's see. This value can be neglected. Very small value is there. What is the answer? A you are getting? Is it A? Because when you will substitute these all the value, A will come in. Definitely right answer. Yes. Yes. You just substitute the value of P from here to here, you will get the A answer. Good. Abhi, I think this question may be the new for you. If I'm not wrong, whatever previous question we have discussed, this one may be the new for you. Because you are not aware with the van der Waals equation, is it or not? A reversible heat engine receives 75 kilojoule per second of energy from the reservoir that is maintained at a 750 Kelvin. Does 12 kilojoule of second work? Heat is rejected to the two reservoir that is maintained at 650 and 550 Kelvin. Rate of the heat rejection to the reservoir at a temperature of this one. Again the new question for you, Abhi, but maximum of you are able to write the correct answer of this question, my dear. Sir, there is one single reservoir that is maintained at 750 Kelvin. After that, there is the reversible heat engine. It is already clearly mentioned in the question. Reversible heat engine. Work is done by this 12 kilojoule per second, my dear. How much energy? Energy is taken from here. 75 kilojoule per kg per second, and after that it is rejecting the heat to two reservoir. Like this one is what should I write? 650 Kelvin, and my dear, this one is 550 Kelvin. How fast you write the answer? All of you, how fast you can write the answer in this? 650, 550, 750 Kelvin is there. 75 kilojoule heat is supplied to the system. 12 kilojoule of work is done by the system. So if I'll write like this as a Q2 and if I'll write this as a Q3, then we know very well that Q2 plus of Q3 from here, it will be equal to 75 minus 12. What is this numerical number? 65, or इसमें से दो और कम करो, can we write 63? We can write Q3 will be equal to 63. We can write Q2 63 minus of Q2. Again, reversible heat engine is there. Can be apply the equation of Clausius inequality law, that is del Q by T will be equal to 0. Like, very good. 750 divided by 75. उल्टा लिख दिया, ऐसा कैसे? 75 divided by 750 minus Q2 divided by 550 minus Q3 divided by 650 is equal to 0. This is 10 times 1 by 10. So Q2 is 63 minus of Q3 divided by 550 minus of Q3 divided by 650 minus plus will be equal to 1 by 10. In this way, when you get the value of the Q3, it is exactly 52. बिल्कुल सही है. Absolutely right. It is exactly 52 answer we all are getting, my dear. Good. Next. A piston cylinder arrangement has a initial volume of this one. Initial volume of this one contain an ideal gas CBR is equal to this one at a pressure of this one and the temperature of this one. P1, T1, B1 all are given. The piston is moved to compress the gas until the pressure and temperature P2, T2 are given to us. During this process, work done is done on the gas. Oh, very nice. Work is done on the gas, my dear. 20 kilojoule. What is the magnitude of the heat supply? First law of thermodynamic आपको पहली लाइन में आंसर देके जा रहा है. If you follow the basic formula of the first law of thermodynamic, you can't make the mistake in this type of problem. गलती हो ही नहीं सकती. Work done is already given. We know very well what is the change of internal energy in the system. MCV delta T. T1 and T2 both are directly given to us. Temperature is increasing, my dear. Temperature is increasing, that's why internal energy will also increase. Internal energy increasing, work is done on the system, heat will be supplied to the system. Can we write change of internal energy? This is kilojoule is given, so that will be equal to M Cp T 2 minus T1. M will be equal to P1 V1 divided by RT1, my dear. Is it or not? Cp. That will be also equal to T2 minus of T1. It's not Cp, sorry, Cv. It's not Cp, it's Cv. Because it is the change of internal energy. So it can be written P1. How much is the value of P1? 150. V1 0.1 divided by R1 0.288 into T1 298, T2 423. अब तो आंसर बताओ जल्दी से कोई. I am not getting any answer. 298. What is the numerical value we all guys getting? 423 minus 298 multiply by 150 multiply by 0.1 divided by 0.287288 divided by 298. Answer we are getting 21.84 plus minus 20. Answer is 8.2. Is it or not? This is the answer. Is it or not? Anything wrong we are getting? 423 minus 298 multiply by 150 bar, that will be in kilopascal, multiply by 0.1 divided by 298. Okay, and divide by 0.288. Okay, multiply by something is left. What is this? Multiply by Cv is not multiply here. Yes, Cv is 0.74. So 16.16 minus 20. We are getting 3.83. Yes. You are right. We are getting 3.83. Absolutely right. Yes. Because this value is coming 16.16, my dear. Kilojoule. Change of internal energy, change of the work done, and you will take the difference, you will get the answer. Yes. Question number 13. A reversible cyclic device absorb the heat of this one reservoir at this one reject. And what is the magnitude of the work done? I think very easy question. No need to discuss this. Yes, fourth one. In a reversible process, ideal gas CPR is given, is maintained at a temperature of 293, is compressed in a cylinder from this pressure to this pressure. During this process, relation between the pressure and volume expressed like this, PV raised to N is equal to constant, perfect example of the polytropic process. Then mark the kilojoule value of this entropy generation or entropy change per kg of the ideal gas. Important question is there. Polytropic process is there, my dear, and in this polytropic process, P1, P2 is given, T1, T2 is also given, because T2 you will calculate from here. We can write directly that T2 by T1 from here. We can write directly, do the calculation faster than me, n minus 1 upon n, where P2 is 5 divided by 1 raised to 0.3 divided by 1.3. So from here T2 will be equal to T1 293 into 5 raised to 0.3 divided by 1.3. Can you please tell me the value of T2? T2 will be equal to 0.3 divided by 1.3 multiply by, my dear, 293. Answer is 424.78 Kelvin. Yes. T1, T2 known, P1, P2 known. Are we not able to find the change of entropy? Three basic formula to find the entropy, change of entropy. Either it is the problem of pure substance, maybe the problem of ideal gas, or it is the problem of source and sink. Definitely it is the problem of ideal gas. So apply the formula. What the change of entropy, my dear, for an ideal gas? We know very well, mass is 1 kg, so it will be equal to Cp ln T2 y T1 minus R ln P2 y P1. I think all of us are aware with this simple level of formula. Sir, Tp, Cp is 0.1 point, this one, ln, what is T2? 422, 24.78. What is T1? 293 minus R is 0.297 and P2 5 divided by 1. I mean 500 divided by 100. I have just written, and this is also with ln. Sorry. Can you please tell me the answer? What exactly answer we all are getting, my dear? This is ln 424.78 divided by 293, 0.37 minus ln 5 multiply by 0.297, 0.478. What we are getting? Minus 91. When we solve it, we are getting minus 91 as the correct answer. Good. A is the correct answer. Question number 15. Little bit difficult problem. ऐसा नहीं लग रहा है हेमांग ये क्वेश्चन वहीं से आ रहे हैं जहां से थर्मो में, मैकेनिकल में जनरली क्वेश्चन नहीं आते. सब्लिमेशन, एप्लीकेशन ऑफ क्लॉसियस-क्लैपेरॉन इक्वेशन, application of Clausius-Clapeyron equation. The sublimation process of water vapor at this temperature, my dear, this T set 1 is given to us 233 Kelvin, and P1 is also given to us, that is 30, yes sir, exactly 30 kilopascal. After that, assume water vapor R is given, latent heat is also given, DH latent heat is also given, that is 2840 किलो जूल पर केजी. तो वो जो लास्ट वाला पार्ट है थर्मल में वो छोड़ के मत चले जाना. लास्ट वाला प्योर सब्सटेंस, क्लॉसियस क्लैपेरॉन इक्वेशन, जूल थॉमसन कोफिशिएंट, आफ्टर दैट ऑल थर्मोडायनेमिक रिलेशन फ्रॉम द मैक्सवेल इक्वेशन. जूल थॉमसन कोफिशिएंट not like this 0 positive or negative, no, there is also, yes, there is also some value, some numerical formula of the Joule Thomson coefficient in the term of pressure and volume differentiation. CPCV is also the formula in the term of pressure and volume. Slope is also given. तो ये सारे फॉर्मूले मत भूल जाना जो लास्ट वाले. इवन इन द मैराथन सेशन ना, आई हैव जस्ट रिटन each and every formula on a single slide. Okay, so we know very well. From here we can write ln P1 by P2 will be equal to change of enthalpy divided by R, 1 by T2 minus 1 by T1. Is it or not? I think you are already aware with this formula. Clausius-Clapeyron equation is there, my dear. So in this case, we can easily write ln. This P1 is given to us 13 kilopascal. P2 I need to find. Change of enthalpy 2840 plus 0.46. 1 by T2. How much? T2 is the value 213. Yes, 213 minus 233. Find the value of P2, what exactly we are getting, my dear. Find the value of P2, what exactly we all are getting from here. Let's see. No, not a right answer. You have taken something wrong. Reason do you know? Sir, if the temperature is 213, then definitely pressure must be less than 13. If the pressure is increasing, then saturated pressure temperature will also decrease. Now, in this case, when you solve, we'll get the value of the P2 is equal to 1.06 if I'm not wrong. That is Pascal. Just check it. I think you have done some calculation mistake if I'm not wrong. ये छोटी छोटी mistake है. अब exam time में हम इसको थोड़ी सोच रहे हैं कि it was in denominator or numerator. I have done the multiplication or I have done the division. These small mistake will create a lot of problem for us. ये छोटी छोटी गलतियां जो नहीं होनी चाहिए. ठीक है. Oh. Very lengthy question to read and very easy to solve. It looks very lengthy whenever you start to read this question. In the heating and humidification process, dry air with the relative humidity of 10%, RH is given to us. Let me write each and every parameter somewhere here. That RH1 is given to us 10%, my dear. Yes. Sorry. At a temperature of T1, it means dry bulb temperature is also given to us, that is 10 degrees centigrade. It's mixed with the superheated steam at a temperature of this one. The resultant mixture is 20 degree with the relative. Okay, so T3 become 25 degrees centigrade, and this RH2 become, how much is the value? That is 50%. After that, what is the question? The total pressure before and after is same. It means barometric reading is given to us. Barometric reading is given to us 102 kilopascal, my dear. Wonderful, wonderful. After that, the saturation pressure, I mean PS1 and PS2 is also given to us. What is the PS1? PS1 is given to us 1.2281 kilopascal, and PS2 is also given to us 3.1698 kilopascal. अजय, वेरी गुड इवनिंग. कहाँ थे भाई अभी तक? आई हैव ऑलरेडी आस्क्ड टू योर फ्रेंड हेमांग, तुम्हारा दोस्त कहाँ है? ऐसा तो नहीं कि सोता रह गया है. आ जाओ वापस. वर्क हार्ड माय डियर. ओनली 2-3 days is are left, but let me tell you, XC exam may not help in the selection of PSU, but again, if you are very much interested for the job, either in private or government, then definitely NITI Bombay is the best option from XC. Some IIT are also the best option from this XC, my dear. IIT Bombay, XC score is only required. तो अभी भी गया नहीं है. हाँ, इतना जरूर है, टू बी वेरी ऑनेस्ट. मतलब ऐसा नहीं कि अपने सच्चाई को छोड़ दें. टू बी वेरी ऑनेस्ट, गवर्नमेंट जॉब शायद इससे नहीं मिल सकती है, बट अभी भी देयर आर लॉट ऑफ अपॉर्चुनिटी फ्रॉम दिस एक्सी. मतलब आपके पास में एक बैकअप जरूर रहेगा. तो थोड़ा सा सीरियस होने की जरूरत है. हार्डली इन 2-3 days एंड अगेन problem is over. Sir, what is the problem? Let's come to the point. The problem is somewhere like this, that two streams are meeting from here to here. From here, my dear, most air is coming, you know, and from here superheated steam is coming. At this point, my dear, most air is again coming with the modified version. That is 1, that is 2, and this one is third one, my dear. So in this case, property at 1, property at 2 is given. We need to know what is the property at 3. And let me tell you very honestly in this case, sir, if I am able to know the W1, if I am able to know the W2, W1 and W2 is known to us. Sorry, W1 and W3 is known to us. Then the difference of this W3 and W1 is the mass addition. Is it or not? So in this case, first of all, we need to know what is the value of the W1, specific humidity at 0.1. Second, what is the specific humidity at 0.3. So in this case, if I write what is W1, that is 0.622 PV1 divided by PV minus of PV1, my dear. But again from here, what is the value of this RH1? That will be equal to PV1 divided by PS1. RH is equal to 10%, 0.1. PV1 I need to know, and PS1 is equal to 1.1. How much? 1.2281. You will substitute these all the value here. You will get the W1. Similarly, my dear, you will get W3 like 0.622 PV3 divided by PV1 minus of PV3. From here, RH3 will be equal to PV3 divided by PS3. PS3. So RH3 is already given to us 50. PV3 I need to know. From here, what is the value of PS3? 3.181698. 3.1698. So from here, we calculate the value of PV1, PV3. We substitute here, we get the value of the W1 and W3. Sir, and the difference of W1 and W3 will be the mass of superheated steam will be equal to W3 minus of W1, that is 9.067 gram per kg of the dry air. Are you getting any one of you? Yes, Hemank. Ajay, have you got the same answer? 9.067 is the absolutely right answer, my dear. We all have got. Okay. Good, good, good. Absolutely right. Let's solve question number 17. Again, the problem is little bit lengthy, but when you will read all the statement, you feel that solution is very easy. 2-3 question you will see, and I'll suggest to you at least once read the all questions, and if you are able to solve, okay. If you are not able to solve, leave it. छोड़ दो, फिर उसके बाद हम बात करते हैं सबसे लास्ट वाले ऑप्शन में जाके. In the vapor compression system, a refrigerant leave the evaporator and enter the compression in a saturated vapor condition at a temperature of 0 degree, my dear. If I draw the TS diagram on it, it is clearly mentioned first of all the condition of the evaporator outlet. That's why I will draw from here. Like this is the condition 1, that is saturated vapor at 0 degree temperature. After that, the specific enthalpy all are given. All are given at 0 degree, 50 and 250. Okay. The refrigerant leave the compressor with a specific enthalpy. At this point, enthalpy is also given. H2 is also given 300. After that, from the exit of the condenser, refrigerant is throttled to the evaporator pressure. Refrigerant leave the compressor with the specific enthalpy. Leave the compressor. Leave the compressor with the enthalpy of this one. From the exit of this one and this and this and this, if the coefficient, I mean, like this. Some modification you may need to do. I have just drawn the exact diagram, whatever we have read, but as per the question it is or not, we need to discuss. The dryness fraction of refrigerant entering the evaporator means he is talking about what is the dryness fraction at point number 4. It is the question, my dear. If the COP is 2.8, refrigerant leave the compressor. Leave the compressor, my dear, that is H2 value is given to us. H1 value is also given to us. Wonderful. What is the value of H1? H1 is 250. COP is also given to us. How much? 2.8. Then you need to know what is the value of H3 or H4. This will give you the wonderful answer if you will study everything in detail, my dear. COP is given, you will calculate the value of either H3 or H4, both are the same from here, and H4 is in wet region. You will apply the formula and you will get the clear cut answer of dryness fraction. Very easy question for all of you. Can we write from here? If I am somewhere here, can I write the COP, my dear, will be equal to H1 minus of H4 divided by H2 minus of H1. COP is 2.8, H1 is 250, H4 I don't know, H2 is 300 and H2 is this one. So what is the value of H4? We need to know. Ajay, where are you? Why we are not getting the right answer? 50 into 2.8 and 140 minus of 250, it is 110. H4, yes or no? And 110 is HF plus of X HFG. What is FH? 50 plus X. What is HFG? 200. This is HG, this is HF, HFG is 200. What will be the answer? 110 minus 50 divided by 200. Answer is 0.3. Absolutely right. 0.3 is the absolute right correct answer. So are you not feeling? This question is very lengthy to read but very easy to solve. सोच लो एक लाइन में आंसर आ जा रहा है अजय. Yes, good. Question number 17. Let's discuss the question number 18. Long question, easy to solve. Hot air, assume as an ideal gas. Cp is given, gamma is given. Enter the gas turbine at a temperature of 10 bar and 1000 Kelvin. Leave at a pressure of 5 bar, my dear. Subsequently, it expand into the nozzle. Like the question is somewhere like this. The question is somewhere like this. Steam enter or hot air enter from here to here in turbine. After that, it is allowed to enter into a nozzle from the negligible velocity at this point. V2 is equal to 0. Then what is the value of B3? We need to find. This is the question, my dear. This one is the question. This one is state 1, this one is state 2, and this one is state 3. I don't feel that any one of you going to feel the problem in this case. And in this case, my dear, T1 is given to us. And I think P1 is also given to us. Yes. In this case, P2 is given to us, but T2 is not given to us. P2 is how much? 5 bar. P1 is how much? 10 bar. And P3 is also given to us. That is it, 1 bar. Then what is the value of B3? We need to find. Every parameter is clearly given to us. Let's see how many of you are getting the correct answer of this question. Very easy question for us. What is the final velocity if you will neglect the inlet velocity of air to the nozzle? Any idea you are getting? Okay, wonderful. Very good. Let's see. First you find the temperature of T2. Cp and gamma is given. That's why it will be equal to T1 and 5 divided by 1 raised to 0.4 divided by 1.4. What is the value of T1? T1 is 1000. 5 raised to 0.4 divided by 1.4. Can you please tell me what is the value of T1, my dear? 5 raised to 0.4 divided by 1.4. Answer multiply by 1000. Sorry, it's a 10 now. 5 to 10 is there. Sorry, it is 1 by 2. It means 0.5. So 0.5 raised to 0.4 divided by 1.4 multiply by 1000. Answer is 820.33. Ajay, 820.33. It is T2. After that, what is the value of T3? That will be equal to, क्योंकि इतना आसान आंसर आ रहा है, आपका इतने जल्दी आ जा रहा है, I'm just a little bit confused. Is something wrong you are not doing or not? So it is equal to 820.33 into 0.2 raised to 0.1 divided by 1.4. What is the answer? Answer is into 2.2 raised to 0.4 divided by 1.4. Answer is 517.94. After that, what is velocity? V3 under root of 2 into Cp. Cp is how much is the value of Cp? 1000 into change of temperature. Change of temperature is 820.33 minus 517.94. Is it? Have you solved like this? Anyone? Hemang, have you solved the question like this? 820.33 minus of answer multiply by 1000 multiply by 2 under root of answer is 777.67. Yes, exactly. Absolutely right. Yes, Abhi. After a long time you have written the answer, but answer is perfect. Absolutely right answer. Okay, okay. Good, good, good. All of you have just selected the right answer. 777.67 is the correct answer. That is in meter per second. Yes. Unit, especially you need to focus. This is also gate question. Abhi, I think you are not aware with this concept. Let me tell you, my dear, on TS diagram in any particular process, the area of the TS diagram is, okay, the area of the TS diagram, हाँ नहीं अभी तो टाइम भी है, अभी तो टाइम भी है आपके लिए. Let me tell you, Hemang and Ajay, he just मतलब so much of junior of you, he just a first year student and he is going to attempt the gate 25 or 6. मतलब प्लान है ऐसा, तो अभी तो उसका मैगी खाने का टाइम भी है. Yes. What is the area of this diagram? That will be the heat supply in this case. So one is this area, my dear. Second is this area. Area of this entire diagram will give you the answer of the heat supply. What is the area of this? Can we write heat supply will be equal to how much? 300. Yes, exactly. अभी just वो first year में है. I have just interacted with him in app class. First year में है and he is planning to do something. So area of this one multiply by 0.5 plus area of the rectangle, my dear, that is 450 multiply by 0.75, 0.9, that is 0.15. So what is the correct answer I am getting from here? Please tell me the right answer. I think one of the easiest question for all of you. 300 plus 4, and let me tell you, this is the 2 marks problem. Divide by 2 multiply by 0.5 plus of 450 multiply by 0.15. Answer is 255. Absolutely right. That is in kilojoule. Yes, absolutely right. Next, a rigid insulated vessel. A rigid insulated vessel is divided into two parts by the partition. One compartment contains the 12 kg of the oxygen at 200 kilopascal and 280 Kelvin. Other compartment contain the 26 kg of the carbon dioxide at a pressure of this one and temperature of this one. Specific heat at the constant volume is given like this and this respectively. partition is removed and gas is allowed to mix in both the chamber. Consider both the gas as an ideal gas, then find the final temperature of the mixture. Like easy question, I think, if you have already studied. This is the combination of the mixture, if I'm not wrong, when two gas are combined with each other and they are making the third gas. That is the gas mixture question. Equivalent R, equivalent Cp or Cv, my dear. Are you getting this point? Can we write like this? If it is the chamber like this and after the mixing they are making the third gas, if you don't mind, can I write total internal energy as a final will be equal to U1 plus U2, if you don't mind? What is the total internal energy at the final? It will be equal to, my dear, M1 CV3 sorry into T3 will be equal to M1 CV1 into T1 plus of M2 CV2 into T2. Is it or not? C1, C2 is given to us. What is CV3? That is the mixture. Are you aware with this? What is M3? M3 is M1 plus of M2. And what is CV3? That is the equivalent, my dear. Can we not write? M1 CV1 plus of M2 CV2 divided by M1 plus of M2. मैं एक मिनट को साइड में हट जाता हूँ so that you can check the proper formula, my dear. T3 that will be equal to M1 CV1 T1 plus of M2 CV2 T2. Check it. Is everything okay or not? Are you getting this formula properly or not? Have we studied this formula somewhere or not, my dear? This will give you the value of T3. Any doubt? Any problem in it? Sir, W is 0. No. W is not 0, my dear. If it is a rigid insulated, now this one. If it is a rigid insulated vessel, what is the meaning of it? Let me tell you. Rigid insulated vessel का मतलब होता है that no amount of the heat is transferring from this vessel and no amount of the work is done on or by this vessel, because rigid means no gas is leaving the system and insulated means no heat is coming or going out to the system. That's why final temperature can be given by this formula. That's total internal energy of gas 1 and the gas 2, my dear. It will be the summation of both. It will be the summation of both. So from here we can write as a final formula that T3 can be written as, yes, exactly. Because V is constant, that is the work done is constant. Work done is 0. And this is purely insulated. Insulated means no transfer of the heat, my dear. So this can be written M1 CV1 T1 plus of M2 CV2 T2 divided by M1 C1 plus of M2 CV2. When you substitute all the values, M1 is 12 kg, M2 is 26 kg, T1, T2 360, 280 and 360 respectively, C1 0.662, 0.653. So answer we are getting 334.52 Kelvin. Yes, absolutely right. Hemang, absolutely right. Your gas mixture, van der Waals equation and pure substance में Clausius Clapeyron equation, इन 3-4 टॉपिक को बहुत अच्छे से करके जाना. Yes. SFE is not required in this case because system is properly closed, my dear. It is clearly given. System is purely closed. Exactly. Yes. These 3 topics are the very favorite topic. That thermodynamic relation, gas mixture, one of the important, one of the favorite topic of the XC, and after that, my dear, pure substance. Even in the pure substance, where in the pure substance the slope of TP diagram is asked. Simple Clausius Clapeyron equation I am talking about, right? ये 3-4 टॉपिक बहुत अच्छे से करके जाना. 21. A rigid adiabatic container 1-2 part initially this. Okay, I think same question is there. In this case, in place of temperature, pressure is given to ask. Pressure is asked to us. So I think no problem in it. कोई इसमें दिक्कत ही नहीं है. Let's come to the last question. This one, my dear. Important question for all of us. A thermodynamic cycle is given to us. A given mass of a simple compressible substance undergoes a reversible cycle shown in the PV diagram. The magnitude of this net work during the cycle is 3 kilojoule. In this cycle, total amount of the work done is 3 kilojoule. Then what will be the numerical value of the PC? What exactly given in this case? Hemang, Sroth, very good evening. अब जाने का समय आया तो अब आयो. भी जाने का समय आया तो अब आयो sir. Okay, I am just a little bit late. I have the doubt in 8th question, 18th question. How you find V3? Can you please explain? Okay. V3, 18th question. 1 minute. Just a minute. कहाँ बात कर रहे हो V3 की? V3, okay. Sir, we know very well now that if we apply the SFE, neglecting the heat transfer and work transfer and potential energy, then my dear, we can easily write in this case that V3 is square minus V2 is square divided by 2 will be equal to H H2 minus H3. We have already studied in SFE. Yes or no? So in this case, V3 square will be equal to V2 square plus of 2 H2 minus of H3. V2 is negligible H per the question's root. Then V3 will be equal to under root of 2 H2 minus of H3. Okay. The same formula I have written. After that, I have substituted the value of H2 and H3 by Cp delta T. Clear? Chaliye. Tell me the answer of this question. Question number 22. Sorry. Yes, I forget to add. Yes, Hemang. Sorry. Tell me the answer of this question. Yes. Okay, you will solve. Wonderful. Very nice. PA is given to us, that is 10. PV is also given to us, that is 1 bar, my dear. And VA and VC both are the same, that is 0.006. And VV is also given to us, that is 0.021. Oh, I was watching at 2x speed, so I forgot to check. V2 is negligible, it is given in the question. Okay, yes, this is the last question, very important question for all of you. Net work done in this cycle is given. Abhi, let me tell you, area of the closed cycle will give you the answer of, Hemang, dekho to yaar, he is faster than you guys and he has just started. Very good. Yes, he is getting 6 as a correct answer. Is it? He is getting 6 as a correct answer. Is it the right answer? Let's see. First of all, area or the net work done, my dear, it will be equal to area under AB plus of area under BC, my dear, plus of area under CA. In this case, area under CA will be 0. This will be equal to 3 kilojoule. Area under AB will be equal to 10 plus of this 1 divided by 2, my dear, multiply by difference of this, that is 0.015 plus area of this one, that will be the minus area. Do you know minus area? Because it is the compression process. This will have the negative area, that is equal to, my dear, PC plus of how much is this value? PV 1 divided by 2 multiply by 0.015. Let's see how many of you are getting the answer. 3 divided by 0.0 200. This is 200 divided by 11 by 2 minus of PC by 2 minus of 1 by 2, that is equal to 10, 5. That is equal to minus PC by 2 plus of 5. So the PC by 2 will be equal to कुछ तो गड़बड़ हो रही है. What is it? I think we have to multiply this by 10 raised to 2. Why 10 raised to 2? You know very well. 10 raised to 2 because bar will be converted into this one. So this and this will be removed from here. So the answer will be equal to only 2. And that is PC. So this is equal to plus 2 minus 5. It is equal to minus P by 2. Answer will be equal to minus 3. PC will be equal to 6. Nice. बहुत ही सही. Wonderful. Your speed is absolutely tremendous. 6 is exactly the right answer. Good. Keep it up, Abhi. And all the best for all of you, my dear Ajay and Hemang Srut. You are going to write the GATE exam in XC and you are preparing for GATE 20 or ESC 23 or 4, 4 or 5, Abhi. All the best for your preparation. You are doing very well even in the first year. Just keep it up. You definitely make the difference in 1 to 2 year. Yes. Okay. So 6 is the correct answer for you. Okay. So thank you all. XC अभी मत जानो तुम. Yeah, Vijaya, there is question. Sir, GATE PI score fluctuation was more last year. First ranker got 970 score and 28th ranker got 730 score. Number of candidates were appeared was 4,000. Yes, let me tell you, Vijaya, as the number of students start to decrease now, then difference between the rank or difference between the score is quite more. Even in the mechanical engineer, you will never get the difference so much between the score. But even in the XC paper, in the P&I paper, right? Even in the polymer paper जो आप करते हो आगे, जो ये naval paper जो है या फिर aerospace में, इसमें difference score में बहुत ज़्यादा आ जाता है. Between 1 to 10 rank, if you talk about the score, then there is a lot of difference. That is the reason, my dear, in the XC, I'm going to tell you that if you are going to write the XC exam, then make sure your rank, in worst case, you are planning to have the rank less than 50. Worst case की मैं बात कर रहा हूं. Otherwise तो आप इतना करके आओ. Yes. No. This year is also number of student is quite low. This year is the number of student is quite low. I think 16 or 1700 in PI. Because already mechanical students are low now. That's why. Mechanical students are less. That's why. I think 16 or 1700 of students have filled the form. But let me tell you, if you are going to write the GATE exam in XC or PI, my dear, अगर थोड़ा सा भी अच्छा करोगे, then definitely you are having very good chance. बहुत अच्छा chance है. मतलब score करने का आपको 2 दिन में. Because thermal, you are good in thermal. SOM, if you have taken good in SOM, right? Mess and aptitude, you are already you are having the command over it. So definitely you can perform well in this GATE exam. So again, all the best for all of you. Abhi, we are again meeting tomorrow in the app class 6 p.m. whatever I have told to you. Okay. So thank you all. See you again in the next class. Thank you. Take care. Bye-bye. Good night to all. Good night, all of you. Yeah, exactly. That is tough, you can say. Six is the answer, Srut. I have told you, 6 is the answer.